All right, so this is a video on what is called USubstitution. USubstitution is helpful not only with factoring, but it will also become actually very useful if you ever make it on to calculus. There is definitely usage of what we call USubstitution in calculus, and is very important. Okay, so this is going to stretch you a little bit. This one is something that you probably haven't seen before. So I'm going to go over it. So I'm going to start off, we're just going to look at this first quadratic expression up here, x squared plus 10x plus 21. And we want to factor that. And that should be pretty easy for you guys at this point. You can think my a equals 1, so I can just think I need two numbers that multiply to 21 and add to 10. Simple enough. 7 times 3 adds to, or multiplies to 21. It adds to 10. So that means that my factorization is going to be x plus 7 times x plus 3. And that should be easy and take almost no time at all. Now, you're going to look at what is almost the exact same thing, except I'm going to ask you to factor the expression x to the 4th plus 10x squared plus 21. So the only difference, my coefficients are all the same. The only difference is that my squared has been multiplied by 2 here, from 2 to 4. Technically there's a 1 here. My b term, my x term, has been multiplied by 2 to get me to an x squared. And technically this is x to the 0. These are both x to the 0s, okay? So you can see my pattern here. My exponents of these, sorry, I'll do it over here. My exponents of these quadratic expressions follow a pattern that should be familiar kind of from when we were doing linear systems. So my exponents are 2, 1, 0. In this one, my exponents are 4, 2, 0, okay? So you should notice that all I'm doing is multiplying each of my exponents by 2 to get to this bottom statement. So what I want to do, what we're going to do is we notice that. You should notice this pattern. If you have a 4, 2, 0, you could have it, if you had an x to the 6th, x to the 3, 0 pattern, you would do the same thing. I would think that I'm just multiplying my exponents by 2 here, by 3 here, to get to that, and you can factor almost the same way. So this is where the U substitution part comes in. So we see this, I want to turn this x squared, basically, I want to turn that x squared into into a variable that only has a power of 1. So this is math, and you actually do have some power to do some magic here. So we are going to say, I want my x squared to be equal to a variable that has a power of 1, okay? And you can pick that variable because this is math, you can do that, okay? So we're gonna pick that variable, and since we call it U substitution, we usually use the variable U, okay? So I'm gonna say that anywhere I see x squared, I'm going to plug in the variable U. So right here, I'm gonna rewrite this as, this is just plus 10U, plus 10U. Okay, this 21 doesn't have a variable in it, so it just stays the same. Now I have to think, what is x cubed, or what is x to the 4th equal to if I'm turning it into u? Well, x to the 4th is really just equal to x squared squared, okay? And since we already know what x squared is, we're just gonna plug u into this. So this becomes u squared. Okay. So now that I know that x cubed, or x to the 4th equals u squared, I'm just going to replace x to the 4th with that u squared. So u squared comes over here. Now I have u squared plus 10u plus 21. You should see this and think, oh, I just did something like that up here. X squared plus 10x plus 21 should factor the exact same as this u squared plus 10u plus 21, and it does. So again, you're just thinking, I need two numbers that multiply 21, add to 10, we already did that. So this factors right here into u plus 7 times u plus 3. Okay, so we factored this. Now all we have to do is turn it back into our original variable. So we are going to replug our x squared back in. So we know what u is equal to. U is equal to x squared. So we are going to just put it back in original terms now. So I'm going to say that my u is equal to x squared. So I'm going to replace u with x squared. So this becomes x squared plus 7 x squared plus 3. Okay? This is now you have completely factored this. Okay? So this is how we would use U-substitution to solve for expressions that are not necessarily quadratic, but have a quadratic pattern where it goes 2, 1, 0, or some multiple of this. So if this was x cubed, or sorry, x to the 6th plus 10x cubed plus 21, that would just turn into x cubed plus 7, x cubed plus 3. Okay? So you can do that as long as it is a multiple, as long as the exponents are multiples of this quadratic pattern that we have learned already. Okay, so this is called U-substitution because we substitute our variable with u, and then we solve and factor like we normally would, and then replace it back. We resubstitute our variable in for u. Okay, so if you have any questions about this, it's a little bit more challenging. Work with the people that you are working with. Talk to them first before you talk to me because I'm going to be busy helping other people. Thank you.